velocity time graph. The figure below is a velocity time graph. If the total distance traveled by the car is 300 meters, calculate part A, the maximum speed attained by the car, B, the deceleration of the car. So let's start with the first one, the maximum speed of the car. For solving this question, you need to understand the relationship between total distance in a velocity time graph and the area under the velocity time graph. And this is the relationship, that the total distance in a velocity time graph is equivalent to the total area under the velocity time graph. Look at this graph, that forms a triangle. So if you get the area under this graph, which is a triangle, that will represent the total distance. Then this is the height. This is h, and that is what is going to give us the maximum speed, because this is where it goes up to this point. This will give us the maximum speed attained. So if we get that height, that will be the maximum speed. So let's get the total area under that graph, which will give us the total distance. It is a triangle with the height h, and the base is from 0 to 20, that is 20. So distance, which is the area under that curve, which is a triangle half times the base is 20, then the height is h. That should give us the total distance, which is 300. Working out very fast, this one will give you the height as 30. 30 now represents the maximum speed. That is the maximum speed, which is 30 meters per second. Now I've got that, the first part, so that is how we do it. The second part is about the deceleration. What is deceleration? I'll explain that one using this graph. At this point, from 0 to this point, this is where the speed is increasing, so it is accelerating. This is acceleration, where the speed is increasing. At this point where the speed is reducing, look at this. This is where the speed is reducing. This is where we have deceleration. The speed is reducing. Where it is increasing, it is accelerating. To get the deceleration will be given by change of speed, or that is velocity, change of velocity, divided by the change in time. How do we get the change in velocity? We get the final velocity, and this is where we shall have the final. This is the final velocity. This is final velocity, and you're going to denote this one by v1. And then this is the initial. This will be the initial velocity. This will be the initial velocity. We are going to let this one be denoted by v0. Then the time is in the x-axis. Look at the time in the x-axis. We are considering this part that it reduced the speed. So from 8, this is from 8, and this will be the initial time. This is the initial time. The initial time, we'll let this one be t0. Then this is the final time. This is the final time. Note this one by t1. So using that, we are considering only this part. It's important to understand this is the part that the speed is reducing. This is the part where the speed is reducing, and this is what you're going to consider this triangle. That is where deceleration is taking place. So that is, we're considering that part I've shaded in yellow. That is the part that the speed is reducing, deceleration. So therefore, deceleration, go to the solution here, deceleration be given by the change in speed. Say that one you're going to take, change in speed will be the final speed subtract the initial speed. That is v1 minus v0, v1 minus v0. Final speed subtract the initial speed. Then change in time, the final time subtract the initial time. So t1 subtract t0. We input these values. v1, what is v1? Final velocity is 0. Final velocity is 0. As you can see, this one is 0. Here, one will be 0. 0 meters per second. Subtract the initial. It started from here. So at this point, this is where it attained the maximum speed, that is 30. So we subtract 30 divided by change in time. The final time is here, 20. It is 20. Then the initial time is 8. So that will be final time, which is 20, subtract the initial, which is, this is what is going to give us the deceleration. So 0 minus 30 will give negative 30 divided by 20 minus 8, this will give 12. So working out these, you'll get negative 2.5 meters per second. That is deceleration. Or you can simply write it like this. The negative represents the deceleration. So you can say the deceleration of 2.5 meters per second. So you can either write it as negative 2.5 meters per second, or when you ignore the negative, you have to put it in this statement. You have to include this term deceleration. The speed is reducing. So that is how you're supposed to solve that question.